Hello, everyone. I'm very glad to showcase our custom integration between Home Assistant and this HVAC control test bench powered by ESPHome. Okay. Uh, on the left side of the screen, you see our custom Home Assistant dashboard here. And on the right side of the screen, we have the physical hardware. We have relay, LEDs, push button, wired to all wired to an ESP32-S3 microcontroller. This system gives us a full digital control through Home Assistant while maintaining the feel and reliability of the real physical switch. Okay, let's take a look a little bit of the dashboard. Well, the system consists of two tightly integrated components. An ESP32-S3 microcontroller running ESPHome, acting as a bridge between physical relays and the dashboard. And we have a Home Assistant dashboard here, which mirrors the hardware logic, including visual feedback, exclusive activation, and momentary press behaviors of the buttons. Each digital button behaves exactly like its physical counterpart. It remains active until another action is taken. Okay, ensuring consistency between physical and digital inputs. Now we take a look of the hardware. This here is our hardware test bench, our HVAC test bench that is built for safe logic validation before the installation of the final solution in the real equipments. We have here an ESP32-S3 DevKitC-1 mounted in this expansion board. The expansion board is to check the signals is good for that, and to have ports to make the connection easily. Okay, I recommend using this expansion board because that. Okay, we have as well in this case two modules of relay, 4 channel each, and with auto coupled, 5 volts each, and each module is to control the relay, the relay for each equipment. This in the right and the left side we have the three. We are using three as actually from 4. We have the signal for the cooling, the fan, and the heat of the HVAC indoor equipment. And we have this other 4-channel relay module to control the 4 relays for the cooler outdoor equipment. The low cooler signal, high cooler signal, water pump, and dump pump. When each relay is activated, we see this LED turning on. We have a key design consideration. We avoid strapping pins like GPO3 and GPO46 to prevent boot failures. All GPO assignments were reviewed to prevent conflicts, and the logic is mode aware, ensuring relays don't conflict across different states. Okay. This setup let us simulate the full HVAC behavior, the behavior, operation behavior between the HVAC equipment and the cooler evaporative equipment. We can simulate it without connecting to high voltage loads. Okay, let's make a little tour to our dashboard here. At the top, we have our primary control buttons grouped by functions. This first line here, we have the A, B, AC buttons, cool, the fan, and the heat signal. We have in this the cooler evaporative control, the cooler low and cooler high signal, and we have as well here the button for to make override in the water pump and to make override in the dump pump part. Okay. As well, we have a button here to change the operational mode of the system. This button here in digital, we have in the hardware the equivalent buttons physically. Okay. Let's make a little demonstration. First, we start in the off state of here. We can see the state here in the upper side of the dashboard, and we will change to mode 1 8 BAC. In this mode, we can send these signals to the HVAC equipment. Let's start with the cool, and you see that the cooling part and the fan turn on at the same time because it's a condition in this kind of equipment. We can as well send only the fan signal, and you see that the cooling part is off, and we can change the signal to HVAC heat. In this case, still turn on the fan, and the heat part start in this moment. We can as well change to cool. You see that we have an interlock here between the two modes, cool and heat, remaining the fan on. Okay. If we in the simulation turn off the signal, we have a complete turn off. If we turn on, for example, heat, and we deactivate the heat, you will see a delay between the fan and the heat relay, because we need to get out all the heat from the system, and that is why this I will deactivate, and you see that fan is still on, and later it is off. This time, this delay is completely customizable. We can change it to make it last longer. Okay. Note that for this mode of operation HVAC, we have the same functionality with the physical buttons that simulates each signal when I have the button pressed. For example, this signal is cool, and we have cooling and fan active. If I press only the fan signal, now we have the fan only, and if we press heat, we have fan and heat process. Okay. Activated. If I liberate the button, we have the delay of the activation of the fan. Now we will change the operational mode to number 2, que es evaporative cooling, and here we can test the cooler load signal, and you see that we have a delay here between the water pump and the fan of the cooler low signal. If I press the other signal that is cooler high, we have an interlock, and we have the delay as well in between the water pump and the high fan speed. Okay. If I press again low, we can see the interlock between these two relays that I repeat, this one is low and this one is high. And we can simulate this behavior with the physical button as well. Here we have a low, low, and we have high. Start with low. We have the delay between the pump and the water pump and the fan. And if we change to the other, we have an interlock, and in this case we have a change to the high mode signal, keeping the water pump functioning. The delay that we have in this mode is because we need to get wet the interchanger before start the blowing part. I understand that. Well, now we will test the next mode, that is manual mode, in which mode we can override each part of the cooler. We can override the blower in cooler low signal, only this one. We can turn it off. We can turn on the cooler high, only the blower, and turn off. We can override the water pump, and we can override the dump pump. Okay. We can make in this mode, we can make the same with the physical buttons. Cooler low signal, override of the cooler low, override of the cooler high, override of the water pump, and override of the dump pump. Okay. Well, that's it. Note that we have interlock among each operational mode. For example, if let's put again the mode 1 HV. If I have this signal, for example, okay, and it's turning on, and I keep pressing the button, but I change the mode. I will change it in the dashboard. Here you see that the interlock turn off all the previous relay, the relay from the previous mode, to keep the interlock between or among all the operational modes. Okay, the same, you will see the same, you will have the same if, for example, I am in the mode 2 cooler. I am in the mode 2, for example, with the cooler low signal on, but if I change the mode to manual, all the relays turning off before changing the mode to the next one. Okay. Well, this is the test of this logic, and I did a simulation of all the logic that we have already, and how you can see this setup, we can expand it. It could be expanded. We can add new relays or sensor easily with ESPHome. We can create temperature-based automation in Home Assistant. We can as well implement user-based dashboard. We can make improvement in the dashboard, and we can integrate with, for example, motion sensors, occupancy sensors, timers, or with a weather condition sensor as well. We can with this setup, we can improve in this sense. Okay, the difficult part of the code, we have it with this solution. For the next step only is, make a little code change to improve what we need. In that sense, I think we have successfully bridged the this legacy control that we have in this equipment to an all digital home assistant and ESPHome integrated solution. And in that way, if you have questions, comments, I'm very attentive to receive your feedback. And what do you think about this solution? And well, this is all for the moment. I wait for your comments, and see you later. See you then.